All right, we're live. Hello, everybody, and welcome to AP Calculus, technically AB. Today we'll be going over the 2015 free response questions from Calculus AB with me. My name's Brandon. It's so good to see y'all. So in terms of today's live stream, I'm actually going to get to your questions as I address them in the presentation. I think I'm going to answer all of them. Yeah, I will answer all of them throughout today's live stream. So don't worry, your questions will be answered. So yeah, let's get started, I guess. So first of all, you should definitely go follow Fiveable on all of our social media platforms. That includes TikTok, Twitter, Instagram, and YouTube. We'll post updates about content. We'll have, memes that are always really funny and just a variety of things that you should check out because we might let y'all know about something like a sneak peek before the rest of the people know. Also, make sure you check out our weekly streams for all of our AP subjects. We have support for, I believe, 14 AP subjects, ranging from the Englishes to statistics today and social sciences on Tuesday, our sciences on Wednesday, and our histories on Thursday. And by the way, I'm going to give some extra, how do I phrase this? I highly encourage you come to tonight's 8:30 p.m. Eastern weekly current events live stream because I'm going to be there. And it's a coordination between AP US Government and AP English Language, although it doesn't really apply for AP Lang anymore because we don't have the argument essay. But if you're in US Government, you should definitely come check out the current events live stream. It'll help prepare you for stuff. So in terms of calculus, we have a lot coming up. We will have our weekly live streams every Monday at 3 p.m. or 4 p.m. Eastern, 9 p.m. Eastern. The 4 p.m. Eastern slot will be a FRQ review plus a Q&A. And our 9 p.m. Eastern is going to be, our 9 p.m. Eastern stream is going to be on a specific aspect that will be on the exam. So right now we are in an FRQ review, and in 5 hours, we'll have someone live reviewing about existence theorems and justifying and explaining your answers in 2 weeks. So it's super exciting. And also, you should definitely go get Cram Passes. So you can review in up to 22 AP subjects in a variety of ranging from micro to macroeconomics to physics, studio art, art history, comparative government. These are the only thing that costs money at Fiveable. And that's mainly because it's 10 review sessions with about 20 to 30 people where you can ask questions to the teacher who's leading the live stream. They're typically an AP grader or an experienced AP teacher. And financial aid is available. You just have to visit fiveable.me/crampass. And there are AP Calculus, AB, and BC cram sessions that are happening like this week. So make sure to sign up as soon as you can. So yeah, that's all the stuff from Fiveable. So in terms of today's live stream, we'll first be covering College Board's update that came out 3 days ago on, can't count, Monday. I'll talk about what's on the exam, and then we'll get into the review of the 2015 FRQs, and we'll end with a Q&A. Although you can ask questions throughout, and I highly encourage you to. So I'm going to see if I can address any of these questions. Not yet. Okay. Cool. So College Board's update basically says that the Calculus AB exam is going to be on May 12th at 2 p.m. Eastern. The makeup date, if your school cancels or you aren't able to test or for some other reason, the makeup date's on June 1st at 4 p.m. Eastern. Basically, it's 45 minutes. It's online. You'll have 2 free response questions, 25 minutes to do the first free response question, 5 minutes to upload, 15 minutes to do the second free response question, and 5 minutes to upload that as well. College Board has already announced that you'll be able to test the software in late April. So that's going to be very fun and exciting, and I highly encourage you to check your email from College Board. Also, I'm going to paste the 2 URLs from College Board. The first one gives you the links to the test schedule and information about the tests in general in terms of like test security. This is AB Sarthik, but I would say that like some of the FRQs will apply to both. And the second link covers what will be on every single one of your exams. For instance, in the histories, if you're in US history or world history, you'll be you'll be writing the DBQ. And Natalie, I would say that BC has about 4/5 of the AB curriculum, especially because they cut Unit 8. And you can stay for the stuff that will be on both exams. You can also choose not to. That's okay. But for now, I would say most of our students are in Calc AB. So if I were to cover BC content, I would be alienating a larger majority. And I hope that makes more sense. I'm sorry. But we'll have Unit 8 review. I'll cover it shortly at the end in Q&A if I have time. But thanks for coming anyways. We really appreciate it. So yeah, 60% will be on FRQ 1, 40% will be FRQ 2. So I'm actually going to answer Spandon's question here. Where can we get practice for these FRQs? Your teachers can assign you free response questions on AP Classroom, or you can go through past FRQs like we're doing today here at Fiveable. So when you ask if College Board will release a set of practice tests, your teachers should have access to I think it's called the AP Classroom Audit for AB and BC, and they'll be able to give you some free response questions from like past tests, I believe. Okay, and we'll move on. So this will answer 2 questions here. So the first question above was, what units will the AP Calculus AB FRQs focus on for this year's test? The answer is units 1 through 7. So that's differential equations, that's your basic differentiation, integration, and just the usual stuff for Calc AB, with the exception of cutting unit 8, which is finding the average value, position, velocity, and acceleration, area between curves, all of the disk and washer methods, volumes with cross sections, and area between 2 curves. Note that if you are in Calculus BC, 1 through 8 is still on the exam, and that includes integration by partial fractions, I think, and integration by parts. Those will both be on BC, in addition to like logistic equations and things like that. And for BC, also half of Unit 10, I believe, is covered on the exam. So that's like, I think some like the geometric series, the harmonic series, like 3 of the tests. And once again, you can find that all on the first link on College Board. All right, so lots of questions rolling in. What's the best way to study for the new FRQs? Would you say the AP Central ones are relevant? Yeah, I would say the AP Central ones are very relevant, given that they're the makers of the test. So definitely go do those. The best way to study for them is to practice, look at the answer key, and see, grade yourself. My teacher said the exam was focusing more on differential equations. College Board hasn't announced that. And I know for sure that in Trevor Packer's live stream to teachers, he said that calculus would have 2 FRQs, but didn't specify what the FRQs were. So not too sure about that. That might just be speculation. I'm sure they're still going to cover the basic differentiation, things like that. But yeah, I'm sure there will be a differential equation question. Maybe. That's speculation. Okay, so now I can start answering some of these. Justin asks, how and where will we actually log into the test on the test date? All I know is that it's not going to be on collegeboard.org. They'll send out a link at a certain time to your email. You'll get more information from College Board about how and where you'll sign in. Can we still be tested on applications of differential equations? Well, if we look at the Unit 8 outline here, it never says their applications of definite integrals. So my assumption would be that you can still be tested on differential equations as long as it doesn't have to do with volume with cross sections, disk and washer method, that kind of stuff. But you'll still have to separate your variables. You'll still have to do probably implicit differentiation, that kind of stuff. Someone asked, are the FRQs the same as before the changes? No, they're not. It's 2 FRQs. And as you can see from this slide, it says that FRQ 1 and 2 will have parts A, B, C, and D. I don't know how many parts yet, but there will be parts from different units. So you'll have a question on integration, a question maybe on differentiation, that kind of stuff. Are the FRQs all calculator? I actually think they are. They said that you can use a calculator during the test. So it's not going to be like the old exam where it's some parts FRQs, some parts not. And by the way, if y'all can put all of your questions in the Ask a Question tab, just so I don't have to check the chat and the tab. It's just more streamlined for me. Someone else asked, would a question like number 2, which is traditionally, I think, acceleration, velocity, and position. Will that be on the exam for AB? No, it will not. It might be on BC though. I'm not sure. It didn't show up last year for BC because I took the test and I doubt it, but it will definitely not be on AB. Do we know anything about the types of applications? No, we do not know about the types of applications. I would say that the things that they're going to ask you are going to be slightly different than what would have happened before because it's open note, open book. That's something I forgot to mention, that all of your AP exams are open note, but that doesn't mean that they're not going to use the same format from past years because then you can just copy the template and that defeats the whole point of the AP exam. So I'm sure that things will be a little bit different and they're being vague on purpose just so you don't make cheat sheets and just get a free 5, I'm sure. Ooh, lots of questions. Akshita asks, can we go over rate in and rate out problems? That will be the first FRQ that we go over in about 10 minutes. Great question. So there is no acceleration, position, or velocity. No, if you look at 8.2 here, it says that connecting position, velocity, and acceleration is in 8.2 in unit 8, so it will not be on AB. How would the test being open book affect the test? It means that basically College Board will design the questions in a way where you can't just copy a template from past FRQs. I'm sure they will be more word problem based. Once again, that's speculation, but I would just study as if you would have studied without open book, because honestly, in 45 minutes, you can't flip through that many notes anyways. Are the AP exams going to be harder this year, or is it going to be similar to what's already been done by College Board? I would say that it depends on how much you do up until May 11th through May 22nd, because how hard it's going to be is based on how much you study. Honestly, that's what I stand by. All right, went through a lot of questions there. So yeah, make sure that you also submit like unsimplified numeric answers. That's something that they said here for AB, and that's because, for instance, if they ask you to write an equation, you don't have to, for instance, take it from point slope form into slope intercept form, y equals mx plus b. You can just leave it as y minus y1 equals m times x minus x1. You don't have to simplify it to simplest form, at least for calculus, at least for certain questions. In terms of like integration and differentiation, you obviously have to solve and simplify the integral or the derivative. So yeah, that's pretty much it in terms of what will be on the exam. Lots of fun questions there, and I'm happy that I can help y'all get answers to those. So in terms of what we're doing today, we're actually going to do an FRQ review, and I'm just going to swap my screen here. And if you saw there, we're basically doing questions 1, 3, 4, 5, and 6 on the AB exam. I'm going to send y'all the link in case you don't want to follow along on my screen here. This is the AB FRQ. Whoops. And yeah, this should be pretty fun and exciting. It should take about 30 something minutes or so, although it might run longer. We'll just have to see. All right. And what I'm going to try and do is, let's see if this works. Hey, it worked. Okay. So what I'm going to try and do today is I'm going to kind of get an ask and answer. So I'm going to have y'all, I'm going to be like, so for 1A, are we going to do the integral or are we going to do the derivative? So I want to make this live stream as collaborative as possible. So if you can help answer those questions in the chat, I would really, really appreciate it. So yeah, this should be pretty fun. I'm going to be writing on a separate screen here because that's always exciting. Unless it closes. Alrighty. So, we have another question. Okay. To what degree would unsimplified answers be acceptable? Can I leave a definite integral evaluated right after FTC and have it be considered okay? Well, if it's asking for an answer, if you have the definite integral from 3 to 5 of f of x, then you would still have to solve it. What I mean by unsimplified answers is that, for instance, you don't need a factor, or sorry, flip that. You don't need to FOIL out equations, for instance. You don't need to solve from point slope to slope intercept. I would still do what you've been doing in your regular class FRQs. Okay, so we're going to start off with number 1A. This is a classic in and out question. And the way we know that is from the keywords here. So first of all, we have function R, which as you can see here is an in function. Can I zoom out? Okay, so we have our in function, which is R of t, and we have our out function here, which is modeled by d of t. And as we can see, it says drain, and that's our keyword as to why it is an out function. So let's look at number 1. Number 1 says, or number 1a, it says how many cubic feet of rainwater flow into the pipe during the 8-hour interval of 0 to less than or equal to t to less than or equal to 8. So first of all, are we using the in function or the out function? Are we using R of t or d of t? That's what I'm going to ask y'all. In R of t. Yeah, exactly. Great job. So because we're using R of t, right? What R of t gives us the cubic feet per hour, or the rate that it flows into the drain pipe. So to find the amount of water that flowed in, are we going to do a derivative or an integral? Integral from 0 to 8. Great job, everybody. And so here's the thing. This question traditionally gives you a calculator. What you cannot do, you cannot just say, like, for instance, I've seen students write this before. You can't just say, like, 1a equals, I'm just going to make up a number, like 72.3. Because that would get you one of the 2 points, but you always have to write your integral whenever you're solving these questions. So to do that, whoops, I did not mean to erase the actual question here. What we would do is we would do the integral. Ooh, sorry, my handwriting is not the best right now. From 0 to 8 of R of t dt equals, and then we would put it into our calculator. And so it depends on what calculator you have. I know some of y'all might have like TI-83s. I know that you can probably pull up an online calculator for the test. Your school districts will, like, you should talk to your calculus teacher about getting a calculator if you don't have one, because they're very useful. So ultimately, when we put it into the calculator, we find the integral. One of y'all put it into the calculator and tell me what y'all get, or some of you, all of you, put it into the calculator if you have one and tell me what you end up getting. $76.570. And good job. That's the correct answer. And that will get you your 2 points for that question. So good job. Now we'll do part B. So it's asking, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? So my next question from you, and thank you, Paula V, for saying that TI-84 has 6-month subscription for calculators. Thank you for the information there. And also, you can request from College Board. Cool. Do you have any calculator tricks for FRQs to make plugging in easier? Not particularly. I would just plug it into the calc. I don't really know what else to tell you. Just like use your integral function and plug in the function, et cetera, et cetera. Yeah, there's not really like a trick for these kinds of, for in and out at least. Okay, so for part B, it asks for the amount of water in the pipe increasing or decreasing. So are we using just the in function, just the out function, or both? And if we're using both, is it a sum of the 2 functions or a difference in the functions? In minus out. Great job. See, y'all know what you're doing. Y'all are prepared for the exam. So it's in minus out. So in this instance, it's asking if the amount of water is increasing or decreasing. So that means we're checking for what? What are we looking for? Does anyone know? Increasing will be positive and decreasing will be negative. Yeah, great job. So basically, the way I would write this is I would say something like R of 3 minus D of 3 is equal to a number. So in this case, you would plug in 3 into R and 3 into R of t and 3 into D of t. And can anyone put this into their calculator and tell me what they get as a result of R of 3 minus D of 3? What do you get? Negative 0.314. I get 0.3136, but close enough. Negative 0.3136. And by the way you would find R of 3 and D of 3 is basically you would plug in 3 into the R of t function and 3 into the D of t function. Yeah, you literally just plug it in because, okay, so someone is confused. Oh, you've been taught to round to 3 decimals? Sounds good. Just do what your teacher has taught you. Okay. Basically, how this question functions is it's asking if the water is increasing or decreasing. So it's asking if the rate is, if the rate is positive or negative, basically. So the way we figure that out is by taking the in function minus the out function to see if there is a net increase in water or a net decrease in water. Does that sort of make sense? Because if R of 3 is greater than D of 3, so if at time equals 3, the rate at which water flows into the drain pipe is greater than the rate that it drains. So if this number right here was positive, if it was 0.3136, then we would say that the amount of water in the pipe is increasing because ultimately there's the rate that water is flowing in is greater than the rate that water is flowing out. But in this instance, once you find R of 3 minus D of 3 and you get a negative number, that means that the amount of water in the pipe is decreasing at time equals 3. And yes, well, in this instance, they don't really give, I guess you could say feet cubed, but in this case, it's the amount of water in the pipe increasing or decreasing. So I would just answer it in your sentence because it says give a reason for your answer right here. And by the way, in 2 weeks, we'll have a live stream covering justifying and explaining your answers. So you should definitely go check that out. They'll go more into depth about how you justify. So no, in part A, College Board will accept 76.570. But if you write feet cubed, go for it. I don't think it hurts. Good question. All right, we got a few answers. So are you just subtracting the rates? Yes, I'm subtracting the rates at time equals 3. Why is it R of 3 minus D of 3? Because we're checking the amount of water in the pipe and whether it's increasing or decreasing. So if the rate that it's increasing is more than the rate that it's decreasing, then ultimately the amount of water in the pipe is on net increasing. To justify the sentence, how detailed do we need to be to get points? I'm going to get there in just a second. So these rubrics sometimes say that it's okay, that an acceptable response is R of 3 is less than D of 3. Would it be okay to use R of 3 minus D of 3 is less than 0? Yes, it is completely, it's the same thing. And I think College Board will accept either one. So then I would write, this is less than 0. And so then I'm going to type this out because my handwriting is very poor on a computer. So my justification would look something like, since R of 3 minus D of 3 is less than 0, or I would say, the amount of water in the pipe is decreasing at time t equals 3 hours. Or you can say, since R of 3 is less than D of 3, the amount of water in the pipe is decreasing at time t equals 3 hours. Something like that. So technically, sorry, it did not post there. Yeah, bit paper, and I know my profile picture is covering it a little bit, so let's try and move it. There we go. So, what College Board says is that their second one is what they want, and so honestly, I would probably do the second one. At least that's what I did on my in and out questions last year, just because it makes the most amount of sense in my mind that the rate of increase is less than the rate of decrease. So I would say it's the same thing, but to be safe on the AP exam, I would write R of 3 is less than D of 3. Okay. Is it necessary to put answers into a written form? Whenever they ask you to give a reason, you must answer in a written form in a sentence, like I did next to that red star. Okay, if there are no further questions, we'll move on to our next part of the FRQ. There we go. So the rate at which rainwater flows into a diagram, sorry, this is part C and part D. So same functions here. So we have our in and we have our out. So I see here that someone said they had trouble with minimums and maximums. So just to review, how do we check if something is a minimum? What has to be what? What condition has to be satisfied in order for something to be a minimum? And I see someone said the first derivative test, but let's be a little bit more specific. What specifically has to happen in order for something to be called a minimum? Derivative needs to be 0 and s. X equals a, has to go from positive to negative, negative to positive. Endpoints or critical points must be less than all other values on the function. Yeah, so basically the first derivative has to go, or sorry, the function itself has to go from, or the first derivative has to go from positive to negative, or negative to positive. Slope needs to change from negative to positive, yes. So that's something that you want to think about. So I would literally like do it in your head, like the slope is going down, 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 it's going negative, and then it goes positive. Something that you don't want to mix up. So be very careful. Those are relative minimums, and typically I haven't seen an absolute minimum question, but if that does show up, in that case, you check endpoints. And in this case, for part C, that's partially what we'll be doing here. So let's look at C. At what time t 0 less than or equal to t less than or equal to 8 is the amount of water in the pipe at a minimum? What's the difference between absolute and relative minimums? So it just depends. If they give you an interval and they say, is the amount of water in the pipe, at what time between 0 and 8 is it a minimum? That's a relative. Absolute means you take the function as a whole and you find the extrema in terms of where it's minimums and maximums. So in this case, it's just saying when evaluating from 0 to 8, where is the minimum? Where is the minimum? Yeah, then in that case, it's a minimum in terms of the interval from 0 to 8. And don't worry, like typically you won't need to justify by saying like, this is an absolute minimum. You'll just say it's a minimum at this time. So this is how I would do the question. So first I would write out something along the lines of the amount. Sorry, I'm not necessarily paying attention here. Yeah. So I would say something like the amount, I'm just going to shorten it. The amount of water in the pipe at time t from 0 to less than or equal to t less than or equal to 8 is, so can anyone tell me what our integral function would be for the amount of water in the pipe at time t 0 less than or equal to t less than or equal to 8? What would it look like? And I'm going to give a clue. There's something right here that's pretty important that I just bracketed. So many of you are getting part of it. Yeah, there we go. So there is an initial condition. So this is where reading carefully matters a lot. So you do have to add 30 to the front. So I would write something like 30. And in this case, we're not even talking about, we don't have to talk about 0 to 8 just yet. So I can say something as simple as 30 plus 0 to t of r of x minus d of x dx. Okay, so that's our setup. And so in this case, then we have to evaluate r of t minus d of t equals 0. So at first, we have to look, when does this is technically the first derivative, right? So when does the first derivative or the difference in the first derivative equal 0? So let's, oh, sorry, I can see again that my text is covered by my profile picture. Sorry about that. So I'll move that there. Once again, sorry for the rough handwriting, but writing with a stylus is very interesting. R of t minus d of t equals 0. So can someone, let's put it into our calculators and tell me at what point does R of t minus d of t equal 0? At what values? (3.272). Do R of t and d of t represent first derivatives? Yes, because remember R of t and d of t are given as rate functions, Akshita. 0 and 3.271. Yep. And in this case, I would also evaluate 8 because it's the end of the function, even though technically the first derivative isn't equal to 0. So what I would do, and what I was taught, is to make a t-chart. So I'm going to make that t-chart right over here. So my t-chart for part C, and remember on the exam, typically it's like going to be box by box. So there'll be a box for you to answer. Whoops, did not mean to throw that. There'll be a box where you answer part A, a box where you answer part B, a box where you answer part C, and a box where you answer part D. It's not all on one page. So you'll have space, don't worry. And don't forget, you can also handwrite your answers and take a picture for College Board to see. They're cool with that. So for this one, I would create a t-chart, T, and then I would say something like amount of water. And I wouldn't shorten it on the real thing. I'm just shortening because I'm kind of out of space. So then I would plug in my values here for my calculator. So at time 0, once you plug in R of 0 minus D of 0, you'll get that the amount of water is 30. And that's actually given, sorry, that there's 30 cubic feet of water at time t equals 0. Then I'll find 3.271, whoops, or 3.272, same thing. And the amount of water there is around 27.964. And then at time t equals 8, which is the end of that 0 to 8, it's 48.543. Okay, and remember I got these by just plugging in t of 3.271,658, t of 8, t8 into r of t and d of t. Yeah. And so I got 27.964 Akshita by plugging in 3.271 into the function, into r of t minus d of t. Good question. Okay. How does the uploading work? Rishika, I think College Board will be announcing like a test, like a simulation where you can practice uploading and stuff. So they will detail more specifics later in late April. Yeah, Akshita, I plugged in 3.272 into that first function and 3.272 into that second function to get 27.964. Okay. And so then this isn't it. We're not done yet. We have to answer and we technically have to justify, but I would say that this to some extent gives that justification here in part C. So then you can say something. I'm going to type this because once again, messy handwriting. Okay. And it will appear on the screen very shortly. Okay, and so that would be my justification for part C. The amount of water in the pipe is a minimum at time t equals 3.272 hours. And if I needed to justify, I would say because r of t minus d of t equals 0 and something like that. Okay, and so let's do part D now. The pipe can hold 50 cubic feet of water before overflowing. For t greater than 8, water continues to flow in and out of the pipe at the given rates until the pipe begins to overflow. Write but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So this is just setting up an integral. So it says write but do not solve. I want to see if any of y'all can nail it right off the bat. So try writing it in the chat what you would think the answer to D is before I solve it out here in the bottom right corner. And if you don't know, that's okay. We'll work it out together. Got a lot of good answers here. Some of you are very close. So what you got to remember is that the time is W when it begins to overflow. Whoops, didn't mean to do that. So whenever you're writing your integral, make sure you put W. Yeah, some of y'all caught yourselves. So yeah, it's basically 30. Sorry, this is part. I'm going to start using different colors. Sorry about that. Part D is basically 30 plus the integral from 0 to W of R of t minus D of t dt at the end, don't forget to write that, is equal to 50. So that's it. It's basically the integral from 0 to W plus 30 equal to 50. And I don't know why I put a second bracket there. Sorry about that. Oh, the bracket is just much larger. So do you all have any questions about number one, the in and out question? And I'm sure that parts of it will probably exist on the exam, but I don't think it's going to be verbatim like this to answer y'all's questions about what it will look like. It'll probably be a little similar. All righty. If there are no, could you clarify your procedure for part C? Yeah. Okay. So it says at what time from 0 less than or equal to t less than or equal to 8 is the amount of water in the pipe at a minimum and to justify. So first, I'm going to write that the amount of water in the pipe is this equation, which is 30, which is the initial condition, like y'all said, plus the integral from 0 to t, that's not -1, 0 to t of r of x minus d of x, and that should be dt too. Yeah, so basically, or those should both be x's. So what I'm doing is I'm setting up the equation for the amount of water in the pipe. So it's just the integral of r of x minus d of x, which is just the integral of the rate differences, plus 30. And so then the way that we find the amount of water at a minimum is setting the first derivative equal to 0, checking where the sign changes, right? So I just write r of t minus d of t equals 0. I literally put that in my calculator. I write in r of t minus d of t on the graph page. I check where that equals 0. And what we found was 0 and 3.271. And so then I plugged in 0 and 3.271 or 272 into my calculator for r of t minus d of t. And I found that the amount of water at those values was 30 and 27.964. So then, yeah, then 3.271 was the minimum, and that was my answer. For the justification for part C, would we have to explain that the lower bound and upper bound yield greater values than the relative minima? College Board, I think this is what the bare minimum is, and I think College Board said that they would give full credit for what I have on this screen here. I'm sure if you did that, you would probably more securely earn your point. I think that's the better way to say it. So it doesn't hurt to add more, but what you don't want to do is write so much to the point where you contradict yourself. So yeah, you can write that. It's up to you. Do what you're most comfortable with, and that's what I'll continue saying. All right, let's move on to number 3. And technically this doesn't show up on the exam, but Riemann sums do, so we'll cover it anyways. So for part A, use the data in the table to estimate the value of v prime of 16. So how would we do that? What's the first thing we would want to do? Does anyone in the chat know? Secant line, use slope, slope, slope. Yeah, so 16 is right here in the middle, right? So all we would have to do technically is find the change. V prime of 16 is basically the middle of those two functions, right? So for part A, for V prime of 16, you got it. It's basically 240 minus 200 all over 20 minus 12. And ultimately that will give us 5 meters per minute squared. And here's where I would put like units. I would always just put units. Does that make sense as to how people got that? Great job, everybody, on that. What good job. Okay, so now let's move on to, are Riemanns on AP or not? They should be. It's not in Unit 8. Yeah, so I think there are 2 ways that you can tackle on Part B. And what I'm actually going to do is I'm going to cross out this first part because you don't need to explain the meaning of definite integrals in terms of acceleration unless you're in BC. But once again, I haven't seen an acceleration question on BC in a while. Why are the units meters per minute squared? Because the derivative of v, the derivative of meters per minute is acceleration, which is meters per minute per minute. Yeah, meters per minute squared. Thank you, Daniela. So for part B, we're going to approximate the value of the derivative of 0 to 40 of v of t dt using a right Riemann sum with the 4 subintervals listed in the table. So we're going to pretend like that 16 doesn't exist. So I think there's two ways that you can do this. The first way is algebraically. I was never that, yes, it would be the total distance Joanna jogs. Great job. Because remember, the integral of velocity is your position, right? I've been taking physics in a while and I haven't done these questions in quite a bit. Yeah, so distance, the amount that you traveled. Okay, so there's two ways to do this. The first is through algebra. So if you remember your right Riemann sums, basically all you're doing is you're taking the right number, you're taking the second one and using that as your height per se, or your length, whatever you call it. So in that instance, I would write something like the derivative or integral from 0 to 40 of v of t dt. Always make sure that you write this integral function, just because sometimes you'll even get points for like just writing an integral, like I did on BC when I had no idea how to do this like polar function question. So it's always helpful that you write integrals and make that a habit. So then the algebraic way would be something like 12 times v of 12 plus 8 times v of 20. And by the way, the way I'm getting these numbers is here we have a change in 12 times v of 12, which is 200. And then here is a change in 8. So that's like the bottom part, like the change in time. 8 times v of 20, which is 240, and then et cetera, et cetera. So that's how you can do this algebraically. I like to do it sort of graphically. I like to make a little sketch because it helps me at least. So, whoops. And so remember, I'll do like a sketch here that a right Riemann sum is like whenever you take the, let's say there's a point here, a point here. Whoops. There's a point here, a point here, a point here. Instead of using this left point, we would use this point as our first, and then up, and then up. So that's our right Riemann sum. So basically, whenever we sketch out our real graph here, and we'll do it in, why not red? It's going to look like this. So we have 0, 0. I'm just going to do like a very rough sketch here in terms of how you would figure this out. 12, 200. That's 200. That's 12. And then at 20, it's 240. At 24, it's 20. And at 40, it's 150. Oops. So then I connect the dots literally, and I treat it like a right Riemann sum. So first you would go up here. So it would be 12 times 200. And that's 12 times v of 12. Then we go 8 over to 20 here. 8 times this height, which is 240. So 8 times 240. And then we keep going from here on out. Then right here, we would do 4 times v of 24. And remember that I'm sure you won't use this later on, but in this instance, remember that it's a absolute value of v of t because velocity, negative, positive, same difference. So then we would go from 4 to 244, something like that. And then we would come back up here and do 16 times 150. So it looks something like that mess of a rectangle. So that's one way that you can, there's like two ways that you can do it. You can do it the algebraic way, which is just the change in minutes, which is our x-axis, and our meters per minute is our y-axis. And you can just do the right point and multiply it by the meters per minute. Or alternatively, you can draw it out like I did because I'm a more visual learner. Why is it absolute value? Because it's approximation of distance. Good question. And once again, this question won't show up on AB, so you probably won't have this issue. And it doesn't necessarily, unless you're justifying the integral absolute value, that's the only time it would apply. All right, I guess we'll move on to the next part. Actually, before I do that, remember that you also need to memorize your midpoint sums, your left-right Riemann sums, and trapezoidal sums. And yes, you would take the absolute value. So you would not multiply by negative 220. You'd multiply by positive 220. So it would be 4 times 220, right? Because it's the change in x. So the subinterval here would be 4 times 220. I'm late because I had class. What are we doing? Hi, Perla. We are going over the 2015 FRQs, basically doing kind of a question and answer. Do you mean summation notation? Yeah, basically. Like, make sure on a trapezoidal sum, you don't accidentally do like area of a triangle and do BH over 2 instead of 1/2 times B1 plus B2 of H, something like that. I don't remember it very well, but make sure you know that kind of stuff. Okay, keep going. All right, this one is not bad at all. Slope fields, probably the easiest way you can get the most amount of points on the AP exam. You just don't want to misdraw the slopes. So the way we do that is we literally just look at the points and plug and chug. So a slope field, remember, just demonstrates the slopes at given points. So for instance, here at 1, 2, it's asking what's the slope? Do you mean the procedure of doing? I just mean make sure, yeah, you know the procedure, like the back of your hand. And I can't cover it because I got to go through these other FRQs, but make sure you know how to do those Riemann and trapezoidal approximations. I'm sure it'll come up like at least once. What are the word problems that could come up with slope fields? I've only ever seen them say sketch a slope field. So maybe someone else is more aware of a word problem that could, you'll usually just get questions about differential equations, which we'll talk about later in number 4. Would using a derivative calculator technically be cheating? College Board doesn't know, and I think you get to use your calculator on the entire exam, but I might not be true. You got to check with College Board on that. So if you can use like a T-Inspire or a TI-84, I don't know why you can't use a derivative calculator. And do I have a camera? Hi. When you have the exam, not sure yet. Okay, so let's look at this. At 1, 2, what's the slope? Can anyone tell me? 0. So does a slope of 0 look like, this is also a common mistake, it goes back to basic algebra. Does the slope of 0 look like this or look like that? Is it a horizontal line or a vertical line? Horizontal, yes. So that's horizontal right there. And then we just keep going. At 1, 1, it would be 2 times 1 minus 1. So 2 minus 1 is 1, and that would look something like that. Here, it's 6 points, so you don't have to do anything here. Here at 1, negative 1, that would be 2 minus negative 1, which is 2 minus negative 1, which is 3. So that's a little bit more steeper. So you do have to show a difference between a slope of 1 and a slope of 2 and a slope of 3, for instance. At negative 1, at 0, negative 1, it would be 0 minus negative 1. That's just positive 1. So it looks something like that. At 0, 1, if it's a slope of 6, it won't be that big. And even then, it'll be like a slope of 6 and a slope of 2. So there will be ways to differentiate. Don't worry. At 0, 1, it would just be negative 1, which is like that. And also another mistake people make is that they forget that negative is this way and positive is this way. So don't mix those up. And you can literally just draw y equals x and y equals negative x if you forget. And at 0, 2, it's negative 2. So it'd be something like that. And that would get you full credit on the AP exam, as long as you don't mess anything up. So now we'll move on to the next part here. Okay, so it says find d squared y over dx squared in terms of x and y. Determine the concavity of all solution curves for the given differential equation in quadrant 2. Give a reason for your answer. Alrighty, So the first thing we have to do is find the second derivative. So how do we find the second derivative? What do we have to do? What's the first step? Derivative of the first derivative, yeah. So technically differentiate using the implicit. So we would do the d of dx of 2x minus y, or 2x minus, sorry, the derivative of y. And that gets you 2 minus dy dx. That's the second derivative. D squared y over dx squared. And so then, yes, you plug in dy dx here, and you get 2 minus 2x minus y. Great job there, Rishika. And so then that becomes 2 minus 2x plus y. And so then it tells you determine the concavity of all solution curves in quadrant 2. So what we have to do is we have to look at quadrant 2. So maybe make a little sketch here and think in quadrant 2, x is less than 0 and y is greater than 0, right? So if we take this here, we're subtracting a negative x and we're adding a positive y. That's going to end up giving us a positive number. So therefore, so what I would write for part B, excuse me, is something along the lines of, I'm going to type this out again because God knows my handwriting is not going to make sense. So if the second derivative is greater than 0 in quadrant 2, is it concave up or concave down? Answer in the chat. It's actually concave up. And the reason why, and I'm going to press enter there. Yep. The reason why it's concave up is if we look at 2 minus 2x plus y, this is the second derivative, right? This is the second derivative. And in the second derivative here, x is less than 0 and y is greater than 0. And it's okay. No need to apologize. We all make mistakes. And that's why you're here, to make mistakes here and not in May on May 12th or May 13th. So in this instance, we would take the negative x, right? And if you subtract a negative x, it makes it positive. And if you add a positive y, it's going to be positive. So this will be greater than 0 ultimately. Can I just say that d squared y over dx squared is greater than 0 for all values in quadrant 2? I think you do need to justify that in quadrant 2, x is less than 0 and y is greater than 0. So therefore, I would still keep it safe and say 2 minus 2x plus y is greater than 0, because I think they want you to show that you can plug in the first derivative into the second derivative. Good question, though. So let's do part C now. Let y equals f of x be the particular solution to the differential equation with the initial condition of f of 2 equals 3. Does f have a relative minimum, a relative maximum, or neither at x equals 2? So what's the first thing we have to do, everybody? What is the first thing we do? In this case, we would not need to get critical points because they gave us the first derivative, right? And so a lot of you are saying set the derivative equal to 0, but that wouldn't get us anywhere. And I guess you could integrate and then solve. No. So what they give us here, now someone said separate differential equation. Ooh, y'all are thinking a little bit. So, okay. It's just asking at x equals 2, is it a minimum, maximum, or neither? You don't need to separate variables for this question. So what will we need to do? If they give us an x and y, oh, sorry. Yeah, for C. Yeah, you can just plug into the derivative. That's all you need to do for part C. So dy dx equals, and you can do the little line thing and then do x, y equals 2, 3. And so 2 times 2 minus 3 is equal to 1. Is 1 equal to 0? No. So then your justification would be something along, I'm not going to even type it, say, therefore f has neither a relative minimum nor a relative maximum at x equals 2, because it doesn't, the first derivative does not equal 0. Can we just plug into the derivative? Basically, just, yeah. Yeah, is 1 equals 0? No. Okay, and part D is, we're running a little short on time. We only have 5 minutes. So I'm going to skip part D and move on. If you need to figure out how to do it, I can send you all the scoring guidelines. And I'll go through procedure for part C in just a second. But for part D, just use the scoring guidelines on page, I think it was page 5. Yeah. And at the bottom, they'll give you some help with that one. So the procedure, all I did for part C is I know all it's asking me is at 2, 3. Is it a minimum, maximum, or neither? And so when you set the derivative equal to 0, the only time it's a minimum or a maximum is if the derivative is equal to 0. So in this instance, the derivative is not equal to 0. So you plug in 2, 3, and you get 1. And because the derivative is equal to 1, it's not a minimum or a maximum. Okay, let's move on. So let's look at part A for number 5. Find all x coordinates at which f has a relative minimum. Y'all can do this without my help. Let's try part A. So answer in the chat, find the x coordinates, and this is a graph of f prime. Note that. Very key. So when is f a maximum? And do bracket interval notation, because you can do that in the chat. Yeah, oh, sorry. There's no interval notation because it's where it's a relative maximum. It's x equals -2. Yes. So why, sorry, I was like, why did I ask them to do interval notation? What is your justification? Why does f have a maximum at -2? Because f prime of x equals 0. Got to go a little bit more further than that, because if f prime of x equals 0 could also be a minimum. So f prime of x does what? It changes from positive to negative. Great job. And remember, don't get those confused. Okay, let's do part B. On which open intervals contained in -3 less than x to 4 is the graph of f both concave down and decreasing? So here, yes, interval notation. Or you don't even have to, on College Board says that you can do the -2 less than 0 less than x less than 2. It doesn't matter. Up to you. So you didn't even have to do it. So when is it concave down and decreasing? Okay, we got -2 to -1, 1 to 3. Or is it square brackets? It would be, it says open intervals, so I would just say it would be open in that case. It's not brackets. Okay. Okay, let's look at this. So remember, if it's concave down, that means that it has to be, f prime has to be decreasing. So the rate has to be slowing down, right? So if we look at it, that only happens because from here to here, sorry, I realize my cursor is not here. From here to here, it's pretty constant. So here it's not concave. First of all, it's not decreasing. And second of all, concave down means that f prime is negative. So it can only be from -2 to 4. And from -1 to 1, it's increasing. So that means it's actually concave up. So so the only time, someone already answered this, that it's concave down and decreasing is from -2 to -1 and from 1 to 3. So great job. Good job, Venkata. Yeah. Okay. And so the reason why is because you have to justify f prime is decreasing and negative on these intervals. Make sure you justify. We're going to go just to an hour and like 5 minutes. Sorry for keeping y'all here. All right. Find the coordinates of all points of inflection. So once again, I don't think y'all need my help for this. This is a graph of f prime. Whoops, did not mean to move that. So when is it a point of inflection? -1, 1, and 3. All right. See ya, Rashika. You can watch the replay for the rest of this live review at fiveable.me/AP Calc. And I'm glad I could help y'all out. because that's what I'm here for. Okay, so we saw that it's at -1, 1, and 3. So what you have to say is the graph of f has a point of inflection at x equals -1 and x equals 3 because it changes from decreasing to increasing. And the graph of f has a point of inflection at x equals 1 because it changes from increasing to decreasing. So for each of the points of inflection, or like for -1 and 3, it's going from decreasing to increasing, so you can group them together. But for 1, you have to say by itself that x equals 1 is a point of inflection because the first derivative changes from increasing to decreasing. Okay, and for part D, does anyone want to try writing out the expression that involves the integral for part D? Given that f of 1 equals 3, write an expression for f of x that involves an integral, and then find f of 4 and f of -2. Can you say the derivative on the first derivative graph is where the points of inflection would occur? Akshita, I would make it explicit. I would say, you can even say f prime changes from decreasing to increasing at -1 and 3. Therefore, it's a point of inflection. That's, yeah, you got to be specific with increasing, decreasing, decreasing, increasing. Like even a sign chart, if you do this and you go plus minus, that won't give you credit. You have to write out specifically that it changes from increasing to decreasing. That's another thing I remember from calculus. Okay, so I think y'all are stuck on part D. That's okay. This is a confusing question a little bit. So for part D, f of x, the first thing we have to do with f of x is we know that it's 3 plus the integral from 1 to x, because that's 1 comma 3, of f prime of t dt. And so then it asks us to find f of 4. So we would plug in 4. It asks us to find -2. And so basically you would just literally plug in 4 and -2. Yeah. So then you would do for f of 1, f of 4, it would be 3 plus the integral from 1 to 4 of f prime of t dt. And in this case, what is the integral of a derivative? Does anyone know? Like what would this give us? The function, yeah. So, and it tells you, sorry, I just noticed this, 1 to 4 is 12. So here it tells you -2 to 1 and 1 to 4. Yeah, so it would technically be FTC, but they give it to you that 1 to 4 is 12. So then you would do, it'd be, I think it's -12 technically. The area is below the curve, right? So it would be 3 plus -12 equal to 9. Whoops. Yep. And so, yeah, I'm not going to do f of -2, but once again, go back up to the link. I'll repaste it if you want to see the work done for the rest. Link to scoring guidelines. All right, and we'll finally end with FRQ 6. Okay, so this is our classic write an equation for the line tangent to the curve at -1, 1, that kind of stuff. I see that there's still 11 of y'all hanging with me. Thanks for being here for an hour and 4 minutes. We should be done. This went way over, but that's because lots of you had questions, and that's a good thing. We'll wrap it up with FRQ 6. So how do we find an equation of the tangent line? What would we do first for part A? Slope. Yep, exactly. And so what we would do with the slope is essentially we would plug in -1, 1 into there. So we would literally do 1 over, first you would do dy dx, do little line thingy if that's what you've been taught, x comma y equals -1 comma 1. And so then that would equal 1 over 3 of 1 squared minus -1. And that ultimately gets you a slope of +1 over 4. And so then for your tangent line, you can literally write y minus 1. So this is our slope, her point slope form. Y minus 1 equals 1/4 x minus x plus 1, x minus -1. So this right here would give you credit for part A. You don't even have to put it in slope-intercept form. Or you can move the 1 over, do whatever you've been taught in class, but this would get you credit on the AP test. For part B, find all coordinates of all points on the slope at which the line tangent to the curve is vertical. So what's the first thing we would have to do? Yes, the denominator equals, see, I'm working with like geniuses here, because when I was in calculus and I was looking at FRQs on April like 5th, no idea what was going on. All of you are extremely capable of getting a 5 on the AP exam. Like, I promise, every single one of you. Perla, no, you don't need to use the little line. You can literally write dyd. You can write x comma y equals -1, 1 above it. It doesn't matter your notation. As long as you just know that as long as you label that you're substituting -1, 1, Perla, you're good. Okay, so for part B, yeah, you set the denominator equal to 0. So 3y squared minus x equals 0. And so then you would get something along the lines of, I'm running out of space here, so I'm actually going to erase part A, write a little smaller. So then I'm just going to move the work over here. I'm going to do the work in blue. Blue. So then I know that x equals 3y squared, right? And so then I can literally, that means that y, and they say above here that consider the equation y cubed minus xy equals 2. So then we can literally write y cubed minus xy equals 2. We can substitute the x as 3y squared. So y cubed minus 3y squared y equals 2. And you ultimately get y equals -1. And so then if you plug in y equals -1 into, into here, then you get x equals 3. And so the tangent line to the curve is vertical. So you would write, you type out the tangent line to the curve is vertical at the point 3, -1. So why did I set the denominator equal to 0? Because the line tangent to the curve at the point is vertical. That's when, so remember, vertical slope, when the line tangent to the curve at the point, when the tangent line is vertical at a point, that means that the slope is undefined. And the only way that we can make the slope undefined is if the denominator is 0, because you can't divide anything by 0. So we take the denominator, set it equal to 0. We get that x equals 3y squared. And then we plug that x equals 3y squared into the above given equation. We solve for y, we solve for x. And so then we know that the point on the curve where the line is tangent to the curve at the point that's vertical is 3, -1. So yeah, then solve the original equation for a variable. So this is the, I think, why do you set it equal to the above equation? Because now that you have x equals 3y squared, that's all you get from the like you get that from the derivative, and then you apply it to the regular, like the original equation. I hope that makes a little bit of sense, at least. So you take the denominator, set it equal to 0. And so then that's how you figure out, that's how you substitute x for, it's just like a system of equations. And so then y cubed minus xy equals 2 becomes y cubed minus 3y squared times y equals 2. That gives you y cubed minus 3y cubed equals 2, which is -1. And then you plug the -1 in back into this 3y squared minus x equals 0, and you get x equals 3. So then it's 3, -1. All right, and we have our final question here. Once again, sorry for running over 10 minutes, but it's good to answer questions. So it says evaluate the second derivative at the point on the curve where x equals -1 and y equals 1. So what's the first thing we do in terms of finding the second derivative? What are the two key words we have to do? And someone said it earlier, but it wasn't used for that question. It's going to be used for this question. The second word is differentiation. The first one, it starts with an I. What are we doing? Implicit differentiation. Great job, everybody. So the way we would do implicit differentiation, basically, you would want to separate, not separate, but you would do 3y squared minus x times dy dx. So this is quotient rule, right? Not going crazy. Yeah. Minus y times 6y dy dx minus 1 all over 3y squared minus x squared. So also make sure you know your classic quotient rule, product rule. Yeah. So as you can see here, I'm doing the first derivative, f prime times g minus g prime times f all over g squared. That's how I remembered it. Yeah. So you do quotient rule with implicit differentiation. And so then once you plug in 1 and -1, I'm going to spare y'all the whole work. You'll get it's equal. So then you'll do d squared y over dx squared with x equal -1, y equals 1. You'll plug this mess into here, and you'll get 1 minus 1/2 all over 16, and you'll get 1 over 32. So yeah, that's pretty much it. Low D high minus high D low all over low squared. I remember that. I never used it, but because I always memorize product rule as f prime g plus g prime f, if that's right. And then f prime, yeah, all that stuff. But yeah, that's pretty much it. And so after you, on the top here, after you basically take the dy dx's, factor them out and all that lovely stuff, you'll get 1 over 32. So really the hardest part of this question is finding the second derivative, which is through implicit differentiation. So yeah, that's everything I had for today, I believe. And if you'll have any more questions, I'll take questions for like 3 minutes because we've run 12 minutes over already, but I'd be happy to answer anything you have related to calculus, related to the AP exams, to Fiveable. I guess I'll switch back to my end. And I'll take questions through the chat or ask a question. Got to run to my next class. Have fun. Make sure you come to the current event stream at 8:30 Eastern, 7:30 Central. I'd love to see you there. All right. So that's pretty much it from me. Make sure you follow Fiveable on all of our social media, including TikTok, Twitter, Instagram, and YouTube. I'm sorry, I know it's not in focus. How would you suggest reviewing for Calc AB? I would recommend coming to these live reviews, doing the practice, engaging with me, engaging with the teacher streamers and stuff. That's always fun. Make sure you come to our live streams in all of our different subjects. Come to our live reviews for calculus later in the day and get cram passes. And now I'll answer questions. Yeah. Cool. So I don't think there are any further questions. So if that is the case, thank you so much for coming, everybody. And for the 7 of you who stuck it through for the hour and 13, although I know people have other classes and stuff. In the future, these FRQ reviews, I'm probably going to trim it down to like 50 minutes max, because I feel like this can get a little bit burnt out. Is Calc BC formatted the same way? Yes, it's 25 minutes for the first FRQ, 15 minutes for the second FRQ. It's going to cover stuff from units 1 through 8. Because they took in half of Unit 10, Natalie, I know definitively that they're going to put a series question on there. So you better study this stuff from series that you need to know for Unit 10. And good luck on BC. Hopefully, maybe next time I'll have some extra time and we'll go over maybe a quick review of a BC FRQ. I'll definitely do that for my BC children. I might even start off with a BC question and then move into AB. We'll figure it out next week. But I might be here next week or the week after. It just, we'll have to see with my schedule. But thank you so much, everybody, for coming. Make sure you tune into tonight's Calculus AB stream at 9 p.m. Eastern and our current event stream at 8:30. And I will see you later. Have a good day. Bye-bye.